students, this is Ripka, assistant professor in mathematics. Today we are going to discussing about how to derive normal equations for a parabola. Before going to that, you have to know the form of a parabola. That is y is equal to a plus bx plus c x square. And before going to that, you have to know the definition of a error. So error of approximation is nothing but the difference between exact value minus approximation value. And secondly, you have to know about the principle of method of least squares. So what is the principle of method of least squares? Means minimizing the sum of squared errors. That means nothing but you have to know that summation means nothing but summation I is equal to 1 to n squared errors. Here what is the error here? yi minus f of xi. So squaring means you have to put whole square. So this is the principle of method of least squares. Okay. The form of a parabola is y is equal to a plus bx plus ax square, and the error of approximation is nothing but e is equal to yi minus f of xi, and the method of least squares means summation I is equal to 1 to n yi minus f of xi whole square. So now you have to start how to derive normal equations. For this, let us you have to consider a parabola y is equal to a plus bx plus c x square. Okay, that means nothing but yi is equal to a plus bxi plus cxi square. And next you have to consider y is equal to f of x be any curve. Y is equal to f of x be any curve. And you have to take, I have already said that e is nothing but error of approximation, that is equal to yi minus f of xi. Okay, let it be the equation 1. So when comparing here, yi is equal to a plus bxi plus cxi square, y is equal to f of x means you have to consider yi is equal to f of xi. So by comparing this, you have to take in place of f of xi is equal to a plus bxi plus cxi square. Clear? That means now e is equal to what you have given, yi minus a plus bxi plus cxi square. So this is the error of approximation. I have already said that before going to that, first you have considered a parabola, next error of approximation, and after that you have to consider the principle of method of least squares. That means what is here? Principle of least squares means sum of minimizing the squared errors. That means let it be capital S. That is equal to summation I is equal to 1 to n. Squared errors means here error is yi minus a plus bxi plus cxi square whole square. So let it be capital S. So here there are some constants are there. First one is a, b, c. These constants are nothing but arbitrary constants. For why we have to deriving normal equations means you have to find the value of a, b and c. For these values we can fit a best curve. So here our motto is you have to find the values of a, b, c. For this you have to you have to partially differentiate s with respect to a. That is nothing but dou s by dou m. It is in the form of x power n, or you can consider x square. So what is the derivative of x square? 2x. By using that formula, now we are going to solve this. That means what is the derivative of x square? 2x. So you can put 2 here as it is. The function what is here? Summation I is equal to 1 to n okay, clear? 2 into summation I is equal to 1 to n yi minus a plus bxi plus cxi square. Okay, but here we are doing partial differentiation with respect to a. Is there any a term here? Yes, here minus a. So when we are deriving we get minus 1. So here another condition is there. You have to equate dou s by dou a is equal to 0. Then only you get a normal equation. So what is dou s by dou a here? 2 into summation I is equal to 1 to n yi minus a plus bxi plus cxi square into minus 1 is equal to 0. Here 2 is a constant. When it is moving that side, you get 0. So summation I is equal to 1 to n yi minus a plus bxi plus cxi square. So this minus 1 is also a constant. When it is going that side, it will be also 0. So what is here? This is equal to 0. Now we are applying summation individually. What we get? Summation I is equal to 1 to n yi minus this a we can written as a into 1. Here a is a constant. Then summation I is equal to 1 to n 1. Next minus into plus, we get minus b into summation I is equal to 1 to n xi. And here also minus into plus, we get minus c into summation I is equal to 1 to n xi square is equal to 0. So now by solving this, we get one of the normal equation. So what's here? We put only positive term here and remaining term we can move to that side. Summation I is equal to 1 to n yi is equal to this negative term. When it is going to that side, it will be positive. So a into what is there? Summation I is equal to 1 to n 1 plus b into summation I is equal to 1 to n xi plus c into summation I is equal to 1 to n xi square. Okay, we will draw a line here. And what we have to do? Summation I is equal to 1 to n yi is equal to, here 1 is moving from n times. So what we have to do here? Na plus b into summation I is equal to 1 to n xi plus c into summation I is equal to 1 to n xi square. This is the one of the normal equation. Okay, no? Here we are derivating with the a. And secondly, what we have to do? We have to derive with respect to b. Same. Here also the formula x square. That means 2 into summation I is equal to 1 to n yi minus a plus bxi plus cxi square. But we are differentiating with respect to b. Is there any b term here? Yes, minus bxi. So what we will get? Minus xi. Clear? So 2 into summation I is equal to 1 to n yi minus a plus bxi plus cxi square. This minus moving to this side. What is there? Xi. Same. Previously what we have done? Dou s by dou a is equal to 0. Here also dou s by dou b is equal to 0. And what we have to get? So see here. Two into summation I is equal to 1 to n yi minus a plus bxi plus cxi square into, there is a some term. What is this? Xi is equal to 0. When this minus 2 going to that side, it will become 0. So what's here? Summation I is equal to 1 to n yi minus a plus bxi plus xi square into xi is equal to 0. Now we are multiplying with xi. What will get? Summation I is equal to 1 to n yi into xi, nothing but xi yi, and again minus a into xi, minus into plus, minus b xi square, and here minus c xi cube is equal to 0. Now we are separating the terms. Summation I is equal to 1 to n xi yi minus summation I is equal to 1 to n a xi minus summation I is equal to 1 to n b xi square minus summation I is equal to 1 to n c xi cube is equal to 0. Only we are putting the positive term here and we are moving negative terms to that side. So summation I is equal to 1 to n xi yi is equal to, so these three terms are negative terms. So what will get? Summation. Here a is constant, that's why we are placing a front side. A is equal to 1 to n xi plus b into summation I is equal to 1 to n xi square plus c into summation I is equal to 1 to n xi cube. This is the another normal equations for a parabola. Okay. First we have find summation I is equal to 1 to n yi. When we will get this? When considering dou s by dou a is equal to 0. And this equation is dou s by dou b is equal to 0. So we have another arbitrary constant, that is c. So for this you have to take dou s by dou c is equal to 0. For this you have to consider, so already we have written this, s is equal to summation I is equal to 1 to n yi minus a plus b xi plus c xi square whole square. Okay. So for this dou s by dou c we are finding. So what we get? Same. The procedure what we have done earlier, the same procedure is repeating here. 2 into summation I is equal to 1 to n yi minus a plus b xi plus c xi square. So we are derivating with respect to c. Here there is a c term. So minus into plus, minus what we have there? Minus xi square. So for this you have to do, so minus we are placing this side, minus 2 into summation I is equal to 1 to n yi minus a plus b xi plus c xi square into, here there is a term that is xi square. So earlier what we have considered, dou s by dou a is equal to 0, dou s by dou b is equal to 0. In the same way dou s by dou c is equal to 0. So for this minus 2 into summation I is equal to 1 to n yi minus a plus b xi plus c xi square into, there is a term nothing but xi square. Now we are equating to 0. So what we will get? Okay, let us see. Okay. So when this minus 2 be coming to this side, it will become 0. So what is the summation I is equal to 1 to n yi minus a plus b xi plus c xi square into, there is another term, it is nothing but xi square. Okay, is equal to 0. Same procedure what we have done earlier, we are repeating that process here. So what we will get? Summation I is equal to 1 to n yi xi square minus a xi square, and again what will get? Minus b xi cube. Next minus c xi power 4 is equal to 0. So now we are separating summation I is equal to 1 to n xi square yi. Here minus a is constant, that's why we are writing in front side. So summation I is equal to 1 to n xi square minus b into summation I is equal to 1 to n xi cube minus c into summation I is equal to 1 to n xi power 4 is equal to 0. The same procedure. We are placing only positive terms here. So what are the negative terms? We are moving to that side. So summation I is equal to 1 to n xi square yi. So here negative term is minus a. It will become plus a into summation I is equal to 1 to n xi square plus b into summation I is equal to 1 to n, what's here? Xi cube. So plus c into summation I is equal to 1 to n xi power 4. This is the another normal equation for a parabola. Clear? Clear? Okay. So now we are recalling this. We have find the normal equations for a parabola. For this, what we have considered earlier, yi is equal to a plus b xi plus c xi square. So just you remember like this. For this, we have get 3 normal equations. But how we have to remember is, just you simply apply summation on both sides. Okay, summation I is equal to 1 to n. Here a is constant, just place here. So what is there? Here a is there, that means nothing but a into 1. So when we are applying summation I is equal to 1 to n for the term 1, what we will get? Simply we get na. Here b is constant. B is constant. Here also we are applying summation I is equal to 1 to n. Here the term there, that is xi. In the same way, how we get? C into summation I is equal to 1 to n xi square. This is the one of the normal equation. When we will get this? If we derive it with respect to dou s by dou I is equal to 0, then we will get this equation. And another equation, just you multiply the above equation, the term with the xi. That's it. Here yi is there, you just simply put xi into yi. We have written n here. That means for which? For the term 1. So for that one, you have multiplying with xi. So what we will get? A into summation I is equal to 1 to n xi. Clear? So b into summation I is equal to 1 to n. There is an already term xi. We are multiplying with xi. What will get? Xi square. In the same way, c into summation I is equal to 1 to n. Here already xi square. We are multiplying with xi. What will get? Xi cube. This equation will get when we equating dou s by dou b is equal to 0. So we have another equation. So you just simply multiply with xi for this second equation. Already xi is there. What will get when you are multiplying xi into xi? Xi square into yi. So a is a constant. Summation I is equal to 1 to n. Already xi is there. I am multiplying with xi. What will get? Xi square plus b into summation I is equal to 1 to n. Already xi square is there. Xi cube plus c into summation I is equal to 1 to n. Already cube is there. I am multiplying with xi. What I will get? Xi power 4. This equation will get when dou s by dou c is equal to 0. So these are the normal equations for a parabola. And now what is your assignment is, I have find the normal equations for a parabola. And what your assignment is, you have to find the normal equations for a straight line. Clear? So I have already written here y is equal to a plus bx, means this is the form of a straight line. Okay, here is your assignment. So before going to do this assignment, you have to know how to construct a table for a parabola. That means why we are using these normal equations means we have to give a best fit for a straight line. Okay, for this, so you just see these three equations. So what are they? Here yi is there, n means the number of terms. So these terms are initially we can see for the given problem, and there is xi and here xi square. All these terms have before summation. That means you have to construct a table like xi, xi is enough and y is enough. What is here? Xi square. Okay, and then xi square is already completed. What is here? Xi cube, and here xi power 4. Is it enough? No. There is xi yi. After that xi square yi. Clear? So like this you have to construct a table. Then you can solve the equations xi yi, xi square, xi cube, xi power 4, xi yi. Here xi means nothing but he given already x1, x2. There are some numericals is there like 1, 2, 3, 4, 5 or whatever it may be. Some numericals up to xn. So this n is nothing but small n. That means number of terms. If there is 1, 2, 3, 4, 5, what's n here? 5. Like y1, y2, y3, y4 and so on, yn. Clear? Xi square means, so what are the terms here in xi? You have to square the terms. Okay, like xi cube, xi power 4, and xi means you have to multiply x1 into y1, x2 into y2. But don't do like that x3 into y2 or y2 into x4 or some other like this. You have to put x1 into y1, x2 into y2, x3 into y3, x4 into y4. Like that. That is xi is completed. Or what is here? Xi square into yi. You have to consider here the column xi square and yi. And you have to multiply with, you have to very be careful. y1 into, what is the term? Here parallel to this y1. And y2 into, what is the term here? You have to multiply like that only. After that you get some values like summation I is equal, summation xi, summation yi, summation xi square, like that you get. So you have to substitute all these values into these three equations. Then you will get these three equations in terms of a, b, c and constant. And you can solve these three equations and you will get the values a, b, c. And you have to put these values in. We have already considered earlier. What is this? Y is equal to a plus bxi plus cxi square. This is the parabola what we have. Clear? This is the parabola what we have earlier. So this parabola will be the required parabola for our problem. Okay? Like this you have to solve for the normal equations for straight line. I think you have already know the form of a straight line. Y is equal to a plus bx. In y is equal to a plus bx, what are the constants a and b? In this parabola what we have done? You can partial differentiate the s with respect to a, then you can equate with 0. In the same way here also you can differentiate with a, b, then you can equate with 0. Then only you get these two normal equations. Like that in our syllabus there are other two functions. So that is nothing but exponential function. Exponential function. So exponential function means exponential function. There are mainly two types of exponential functions. That is y is equal to a into e power bx. Clear? and another exponential function is y is equal to a into b power x. For these two functions also you have to find the normal equations. For this what you have to do is you have to apply logarithm on both sides. Logarithm on both sides. For this what you will get? Log y is equal to log a into, what is the term here? E power b x. So log y is, you have to place like this only, and there is a term you just see this log a into e power bx. It is nothing but in the form of log ab or a into b. So is it clear? Log ab. So how you can written is log a plus log b. In place of a there is a also, but in place of b what is here? Log e power b x. So we have to place log y like this only. So log y, and log a also like this, but just see this log and a, these are opposite to each other. These two are cancelled, and what we will get? b x. Clear? So then log y is equal to what we get? Log a plus b x. So this is somewhat difficult to say or write. That's why we are considering put capital Y is equal to log y. Clear? And put capital A is equal to log a. So a term becoming like capital A and y also becoming y, and just we are simply equating capital B is equal to b and x is equal to, capital X is equal to x. So when we are substituting these four in that equation, log y becomes capital Y and log a becomes capital A and small b becomes capital B. And what about small x? We are equating it to capital X. So y is equal to a plus bx. So what is this? It's a straight line. Already I have given assignment to you. You will get how many normal equations? 2 normal equations. So for this normal equation what we have to apply? Summation. First you have to write is yi is equal to a plus b xi. Clear? Now what we are writing? Normal equations. So for this normal equations, for any normal equation you have to apply summation on both sides. This is the summation I is equal to 1 to n yi is equal to a is a constant, that means a into 1, that means what we will get? N a plus b is a constant, summation I is equal to 1 to n x I. This is the one of the normal equation we will get with respect to a. And another equation is also there. What is that? You have to differentiate with respect to b. When you are differentiating with respect to b, what we will get? Already I have said that you have to multiply the above equation with the xi. So summation I is equal to 1 to n xi yi is equal to, that n becomes xa. So summation I is equal to 1 to n xi plus b into summation I is equal to 1 to n xi square. So these are the normal equations. For this also you have to construct a table. What are those? You have to construct xi. In the same way yi. So yi means what is there? You have to place capital Y is equal to log y. In that procedure you have to construct a table and you have to place all the values in these two equations. Then only you have to solve these equations to get the values of a, b. So after you are getting the values of a, b, you have to substitute in this equation. After that y means log y. You have to place all these equations with respect to these equations and you can equate, and log y is equal to you get some value. So what about y? You have to take this side, you get e power. Okay, this is the normal equations for a exponential function. Thank you.